Hello and welcome to Zetec's webinar on saving time and increasing inspection accuracy with scalable oil and gas NDT solutions. My name is Wayne Waxman. I'm the Director of Marketing at Zetec. I'd like to thank everyone for joining us today. I have a couple of logistical items before we get started. Everyone is in listen-only mode, and we are recording today's session so you can review and listen to it or share with your colleagues in your organization. Everyone who registered for this webinar will receive an email with a link to the recording. Finally, there will be a Q&A session at the end of this webinar, but you don't need to wait until the end of the webinar to send in a question. At any time, just type your inquiry in the questions section on your GoToWebinar panel. Before we begin the webinar, I would like to give a quick overview of Zetec. Zetec is a global NDT leader. For 50 years, we've advanced the science and standards in both ultrasonic and eddy current technologies, setting new heights in inspection performance, productivity, and predictability. Zetec's proven expertise and complete product portfolio serve the inspection needs of our customers worldwide in transportation, power generation, manufacturing, and of course oil and gas. Zetec is a subsidiary of Roper Technologies. Let's get to today's session, which will be presented by Dominique Guéguerre. Dominique is currently the product manager, UT Portable Solutions for Zetec. He has a bachelor's degree in physics from Laval University in Quebec City, Canada, and a master's degree in physics from Institut National de Recherche Scientifique in Montreal, Canada. He has been involved in advanced phased array ultrasonic products and solution development for over 10 years, and has worked with experts in the oil and gas industry worldwide. With that, let's start today's webinar.
Thanks, Wayne. Hello, everyone, and thank you for joining this webinar. My name is Dominique Guéguerre, and I'm the product manager for all UT Portable Solution here at Zetec. During this webinar, I will cover 3 application cases typical of the oil and gas industry and show you how the different Zetec solutions can help improve your inspection result. The fact that Topaz 16 is our entry-level instrument is a testament to how advanced we are. Competitively priced, it really lines up well for a wide range of applications. Let's see what the most affordable Topaz can offer. The Topaz 16 packages a lot of power in a small content. It is the smallest instrument, volume-wise, from all comparable competitors in the market. Topaz 16 is also the lightest, and it still offers a full aluminum enclosure and the best display in its category, with a real multi-touch 10.4 inches that is way ahead of the competition. This multi-touch display is very bright even under direct sunlight and can be operated in wet conditions or with gloves. This instrument offers all that is needed for a full inspection setup. A phased array configuration of 1664 or 16128, and one conventional UT channel pulsing at 200 volts. The Topaz 16 is coming in 2 different versions that both support multi-probe and multi-channel possibility, which is a big advantage since 2 PA probe and 1 or 2 pair of tough probe can be used at the same time. In this case, a simple accessory like the probe splitter module can be easily mounted without any tools at the back of the unit to add connectivity for the second phased array probe and the second conventional tough pair. It also comes with a lot of unique accessories that we will see the usefulness later on. And with the chip ID recognition, the Topaz 16 automatically detects the probe and scanner connected to it for easy configuration and complete traceability. But the power of the Topaz 16 will not exist without the forcefulness of its embedded software, Ultravision Touch. This software has been designed with 2 principles in mind. Take advantage of all the features already available in Ultravision Classic, and keep the interface uncomplicated to simplify the life of the user. With Ultravision Touch, The Topaz 16 becomes the perfect companion for standalone preparation, acquisition, and analysis. No need of any other software, everything is in the box. Furthermore, it is fully compatible with the complete Ultravision software suite for advanced operation. The specimen definition is the starting point in any inspection job. It will be used for calculating the focala, positioning the indication during your acquisition, defining overlays, and other important reference. Ultravision Touch software allows to fully configure the parameter of some already predefined specimens such as plates and pipes, including different types of weld profile. If your specimen shape is not available in the list, a file can be imported and incorporated to the setup. Ultravision Touch also has the built-in tools needed for defining the weld shape and parameter, such as profile, size, position, heat affected zone, and so on. This feature that used to require an additional weld option license for activation is now standard in Ultravision Touch. The ray tracing tool is an invaluable visual aid to define the inspection parameter. It can be configured to display different number of rebound legs and support conventional as well as phase array probes. When preparing a setup, the scan plan visualization and ray tracing tools ensure having the right coverage for the job. Since Topaz 16 offers multi-channel capability, Ultravision Touch can display the combined view of all channels present in a setup in order to review the full scan plan and coverage. It is also possible to switch from multi to single channel display mode with a simple click of a button. The compound scan is another nice feature of the Topaz 16. Compound scanning is a combination of sectorial and linear focala in one channel configuration. In a compound scan, the refracted angle of the beam changes from one aperture to the next. The result is a sweep that has a greater coverage than what traditional linear or sectorial scans are able to offer. Many onboard advanced data analysis features are included in the software. Among them, the volumetric merge function allows to combine ultrasonic data acquired with various acoustic beams from different channels and/or different focala. This merging process compares the amplitude obtained at each point of the inspected volume and creates a new data group. The Polar View is also supported in Ultravision Touch. Polar View is a two-dimensional representation of the data in a realistic cylindrical geometry. For TOFD inspection, Ultravision Touch also offers all the analysis tools you need. The lateral wave synchronization can be used to align the front wave of all A scans on a given channel. Also, the lateral wave removal can be used on the top signal to remove the lateral front wave. The Topaz 16 instrument and the Ultravision Touch software can be combined with the right accessories to create the perfect solution package for all kinds of applications in the industry. 3 of them will be demonstrated here, showing how Zetec's instrument and accessories can simplify your work. First, let's have a look at the inspection of boiler tube using the circuit scanner and low-profile phase array probe. For boiler tubes, the industry requires a full volumetric inspection method. While radiography is traditionally used, it has several drawbacks. It is insensitive to misoriented flaws like planar defects, and it provides no immediate feedback to welders while being disruptive to other activities. Encoded phase array UT technology can be an efficient alternative to radiography for weld examination. However, several challenges arise when attempting to perform inspection in the tight environment inside of a boiler. Major concern with boiler tube is the low clearance between pipes, the small wall thickness, combined with the variety of diameter. Zetec proposed a complete phase array UT inspection solution that addresses the challenges presented. low-profile phase array UT probes and wedge installed on the circuit scanner. The circuit from Gyre Industry is a one-axis manually encoded scanner. With its 11 mm clearance and encoded circumferential movement, the circuit enables rapid and efficient inspection of small diameter pipe butt welds. The scanner can be adapted to different pipes diameter ranging from 0.5 to 4 inches. It has a modular and flexible design which permits quick change between pipes and offers the possibility of a single or dual probe scanning configuration. To fully benefit from the low clearance of the circuit, Zetec offers a specific set of probes and wedge. With frequencies ranging from 5 to 10 MHz and the option between 16 or 32 elements, the extra thin linear array probes allow for maximum detection capability. These arrays are curved with a radius of 35 mm to optimize focusing in thin tubes, and the wedge are designed to reduce the distance to the weld center, allowing for better coverage of the examination volume. Now, let's see a demo of how it works. For the inspection of small welded tubes, the Topaz 16 is used combined with the circuit scanner. With Ultravision Touch, it is easy to configure the inspection. In this demo, a pipe of 60.3 mm in diameter with a thickness of 6.35 mm is considered. The weld is a standard circular V. Once all parameters are set, the user can validate them with the shape editor of Ultravision Touch. Two PA channels are necessary for full coverage. For this inspection, 80 probes of 10 MHz are used with a 60-degree shear wave wedge. With the focal lock calculator, you can visualize all parameters and adjust them to the previously defined weld. The inspector can use the 3D ray tracer to automatically adjust the parameter, or it can be fixed from the list. The second, opposite channel is easy to create since all parameters are copied from the previous one. Only the screw angle and the probe connection needs to be changed. Once completed, it is possible to visualize both channels in the ray tracing tool, thus ensuring correct coverage. Layout view can be customized or loaded from a predefined list. Finally, the scanning parameters needs to be fixed prior to the inspection. Again, it is easy with Ultravision Touch since all parameters are in one user-friendly menu. It is possible to calibrate the scanner resolution if not known. The circuit scanner is easy to fix on pipe from 0.5 to 4 inches nominal pipe size. The PA probes are fixed on each side of the circular weld in dual scanning configuration. The inspection is done with a one-axis encoder in one line along the circumference of the pipe. It is easy to manipulate, with the full inspection done in 1 minute. Data are displayed in real time on the Topaz 16. All data analysis can be done with the Topaz 16 as all tools are embedded in Ultravision Touch. First, it is easy to create volumetric merge channel by combining all 90 degrees beam information or all 270 degrees. Once data is merged, the data analyst can use the soft gate feature to rapidly pass through all details with the intuitive interface of Ultravision Touch. With the Zetec solution, results are easy to interpret. As it is shown here, you can even find defects invisible to radiography. The Zetec solution allows to inspect boiler tube weld from two sides in less than 1 minute in a one-line circular movement. The full skip inspection from 40 to 80 degrees shear wave guarantees a full weld coverage that is perfectly adaptable to any codes and requirements. As opposed to RT, the phase array UT inspection technology is not disruptive to other activities. Also, the Topaz 60s and Ultravision Touch ensure an efficient inspection workflow from setup to analysis with accurate imaging. We will now have a look at one of the most common applications in the industry, the long seam weld inspection. Most construction codes require complete volumetric examination of the welded joint and of the heat-affected zone in the manufacturing process. While radiography has in the past been the commonly used examination technique, it comes with several drawbacks. Safety regulations have become increasingly more severe worldwide, and the use of radiography has been drastically restricted, allowing the evolution to allow encoded ultrasonic testing to replace radiography as the go-to volumetric technique. Zetec has developed an optimal solution for the ultrasonic examination of butt weld on carbon steel plates, pipes, and vessels. The weld solution offers excellent inspection capability with permanent records, a drastic time reduction on the global inspection process, and an immediate feedback for the welders. The solution is really versatile since the combination of the Topaz 16 and the weld crawler allows the deployment of phase array UT and TOFD techniques in a single inspection sequence. These two complementary techniques result in a high probability of detection for a wide range of welding defects and an excellent sizing capabilities. Also, this solution offers all the necessary tools for efficient interpretation of data without the need of a computer. Furthermore, since PAUT is very good in the detection of planar and surface breaking flaws, and TOFD is excellent for embedded flaws, their combination makes this inspection technique an excellent choice for complete coverage and no dead zone. Zetec Weld Crawler is an encoded, manually driven scanner with strong magnetic wheels that can be adapted to different inspection configurations on plates, pipes, and vessels. This scanner carries 4 probes at a time, which allows two-sided weld inspection of longitudinal weld with 2 phase array UT probes and a TOFD pair. Probes are easy to mount and are individually spring-loaded for optimized coupling during the inspection. Now, let's see a demo of how it works. The weld crawler is an encoded, manually driven scanning mechanism that can be adapted for different inspection configurations on plates, pipes, or vessels, and different weld orientation. The basic scanner kit allows for two-sided inspection of circumferential welds from 2.5 inches diameter and up, and for wall thicknesses of up to 2 inches. If long seam welds needs to be inspected, the weld crawler can be converted in less than 5 minutes with just one additional mechanical part. In this configuration, it carries 2 phase array probes and a single TOFD pair for a cold-compliant volumetric examination of weld material and heat-affected zones. The probes are easy to mount and are individually spring-loaded for optimized coupling to the inspection surface. For this demo presentation of the weld solution, the Topaz 16 is used combined with the weld crawler scanner. The specimen considered in this demo is a carbon steel plate with a nominal wall thickness of 19 mm or 3/4 of an inch. It has a commonly used V-type bevel weld. The Ultravision touch software guides the UT operator through an efficient workflow for preparing the weld inspection. The weld geometry, including bevel and heat-affected zone parameters, can be easily configured in the graphical user interface of the Topaz 16. Once the specimen is completely defined, the UT operator can use the proposed setup feature of Ultravision Touch. Based on the geometry, the software will propose a code-compliant setup combining appropriate probes and wedges. As soon as the operator confirms his agreement with the proposed configuration, the basic UT parameter will be automatically set. The operator only has to adjust the correct position on the scanner to allow for optimum detection capability and complete coverage of the examination volume. The content of the proposed setup can be overruled by the operator, and it can be permanently modified to comply with specific company work instructions. The software will create a practical display layout for the inspection, showing the PA-UT channel on either side of the weld and the TOFD channel in the middle. It will also indicate how to position each of the probe holders on the weld crawler. The graphical user interface of the Ultravision Touch Calculator allows to visualize the scan plan for each of the inspection techniques. If necessary, the operator can easily adjust the parameters for the phase array probe or the TOFD configuration. No additional software is required for setting up the inspection. In preparation of the inspection, the scanner is placed with the probe symmetrically on either side of the weld center line. The laser guide can be very helpful to facilitate the installation. Mechanical reference setting in the scanning direction along the weld is done by aligning the center of the first pair of probe with the mark 0 position of the component. Upon hitting the Start button, the predefined inspection sequence is initiated and ultrasonic data is recorded while the scanner is moved along the weld. Because of the phase array sectorial sweeps and the natural divergence of the TOFD probes, complete coverage of the examination volume can be achieved in an efficient single-line scanning sequence, as opposed to the time-consuming raster scanning required for conventional UT. The Topaz unit has the unique capability of providing online visualization of the volumetric merge data group for each phase array probe, in addition to the classic TOFD B-scan. The volumetric merge data groups include response from all ultrasonic beams generated by the array probes and can allow for rapid detection of critical flaws. On the type of weld considered here, a scanning speed of around 1.5 inches per second can be maintained without missing any data. More than 10 feet of weld can be recorded in a single data file, including the video images from the camera. The onboard 120 GB solid-state drive allows to store more than 100 of such inspection data files, and therefore eliminates the need for time-consuming data transfer during the work shift. Previously recorded data file can be easily retrieved using the intuitive Ultravision touch interface. By moving the data cursor, the data analyst can scroll through the inspection data to validate the quality of the recording and to identify critical regions. The volumetric merge data groups are typically used for a robust and efficient analysis process for the signal from the phase array probes. To perform the detailed evaluation of the indication, the data analyst can load dedicated layout optimized for each inspection technique. The Topaz 16 has powerful tools to expedite the detection and sizing process. By quickly positioning the cursor around the indication, the operator can read position and length of the information views and save the information in the indication table. The TOFD technique is very powerful for detection and sizing of embedded flaws, as well as for accurate height sizing of cracks. The Ultravision Touch software includes all measurement tools to facilitate the analysis of TOFD data. In addition, the software provides the typical processing tools recommended by the applicable codes like lateral wave straightening and lateral wave removal. The lack of fusion that was clearly detected in the pulse echo phase array data is confirmed with the TOFD. The UT operator can accurately position the two cursors along the scan and ultrasound axis using the new cursor button menu below the data screen. The length of the flaw is confirmed by the TOFD technique and the height is measured. Similar to the pulse echo result, the information is saved in the indication table. Finally, the toe crack at the near surface is also detected with the TOFD, and accurate length and true wall sizing information can be obtained. When the operator has finished his evaluation of the inspection data, the onboard reporting feature of the Topaz 16 will allow him to build, preview, and save various report types with only a few rapid touches of screen. The Topaz 16 report includes all key information of the equipment used during the inspection for traceability purposes. The comprehensive report generated on the Topaz 16 is the final deliverable of this efficient and successful inspection. With the Zetec solution package, the results are really easy to analyze. Here, we can see the detection and accurate positioning of a crack located on the outside diameter. While the phase array UT makes it easy to locate and size the crack, the TOFD technique is there to confirm length and depth. We have seen that the Zetec solution for the inspection of long seam weld has a lot of benefits. With the Topaz 16, the combination of phase array UT and TOFD techniques in one inspection sequence simplify and accelerate the process. The weld crawler scanner is a versatile tool that is easily adaptable to a wide range of configuration. The Ultravision Touch software makes it easy to set up prior to the acquisition and easy to visualize the data during the analysis phase. With the weld solution, Zetec offers a powerful and easy to deploy solution that is code compliant and will definitely help you increase productivity without compromising the detection and sizing performance. For the final application case today, we will have a look at an innovative corrosion mapping solution using the Zetec NDT paintbrush. Corrosion is a common problem encountered in pipelines, refineries, and petrochemical plants. Reliable detection and accurate assessment of internal corrosion in pipes and vessels is vital for safe operation of installation in the oil and gas industry. Ultrasonic testing has been used for several decades to perform corrosion mapping, but manual inspection method can fall short when trying to combine precise measurement, proper surface coverage, and reproducibility over time. Inspectors face the challenge of combining an inspection technique that offers high detection capability and accurate characterization of corrosion with a scanning process that ensures complete coverage. This is where the pairing of the Topaz 16 with an NDT paintbrush scanner can help. The Zetec solution is an easy-to-use corrosion inspection package that offers the full benefit of phase array UT with a high probability of detection and is easily adaptable from thin to thick part due to its versatility. In addition, the use of the paintbrush scanners offers 2D encoded scanning with precise data collection and an accurate positioning in any direction. This makes the corrosion package from Zetec the optimal solution for reliable corrosion mapping on flat and curved surfaces. The NDT paintbrush is a handheld scanner with two-wheel encoded method which ensure accurate tracking of the position and orientation of the probe. Its strong magnetic wheels allow for smooth movement. It is easy to operate with only one hand, having two accessible buttons on the front for the common operation during the scanning process. Choosing the right probe for the job is key to an effective and successful examination. The NDT paintbrush offers the flexibility to support any type of straight beam probe from various manufacturers. Pitch and catch probes are perfectly suited for thin material with their improved near-surface resolution, while pulse echo probe can be used on thicker materials where more energy is needed. Let's see a demo of how it works. For this demo presentation of the corrosion solution, the Topaz 16 is used combined with the NDT paintbrush scanner. The steel pipe considered here has a nominal wall thickness of 6.35 mm. It contains artificial flaws representative of internal corrosion damage. For accurate thickness measurement on thin components, the use of a dual array probe is strongly recommended. The absence of an interface echo will improve the near-surface resolution, and the detection capability on small pitting corrosion is improved with the pitch and catch technique. To ensure an efficient inspection workflow on site, the Topaz 16 allows to prepare and save setup files for various components in advance. When connecting it to the Topaz 16 unit, the NDT paintbrush will be automatically detected and its mechanical parameters will be immediately read by the Ultravision Touch software. The scanner is basically ready to go. The Ultravision touch calculator supports pitch and catch probes as well as pulse echo probes without the need of additional software. With the calculator and the ray tracing tool, it is easy to set all parameters. The typical screen organization for corrosion mapping includes a position or amplitude C-scan view and the corresponding A-scan and B-scan view. Setting the mechanical reference of the scanning sequence is the only thing left to do before starting the inspection. This can be a real burden with some automated scanner, but the graphical user interface for the paintbrush sequence facilitates this operation, reducing it to simply defining position and orientation of the paintbrush on the specimen. As soon as the NDT paintbrush is moved over the pipe surface, the system accurately tracks the position and orientation of the probe while allowing for a free movement of the scanner. The corresponding phase array UT signal are displayed on the Topaz 16 screen in real time. Data from successive strokes is accurately positioned on the scanning surface, and the covered area can be easily monitored on the C-scan view. This allows the operator to complete the inspection of the entire specimen. Corrosion mapping becomes nearly as simple as painting a surface. As it can be seen, the NDT paintbrush delivers the confidence that no area will be missed. Once a complete region has been examined, the inspection data are rapidly stored on the solid-state drive of the Topaz 16 and can be analyzed immediately or later on. Previously recorded data files can be easily retrieved using the intuitive Ultravision touch interface. There is no need for laborious configuration of the screen display. The inspection layout is saved with the data file. Also, the data analyst can load a previously saved layout from the solid-state drive to make its analysis even more efficient. Amplitude and position C-scan views are both available for evaluating all aspects of the inspection data. The operator can also use the cursor to measure the remaining wall thickness in specific location. As the cursor are moved in the C-scan view, the corresponding A-scan and B-scan data are automatically visualized and can be used for more detailed characterization of specific indication. Dedicated info field for corrosion damage assessment display key information about the surface area shown on the screen. Minimum and maximum thickness in the examined region are indicated, as well as the area where the thickness is below the user-defined threshold for the given component. On flat surface or large cylinder, the typical region that will be covered in a single scanning sequence is roughly 2.5 by 2.5 feet. Many times, the region of interest is larger than that. Therefore, it may be necessary to merge data together to give the data analyst a global view on the status of the component and for final reporting to the customer. The C-scan stitching feature in Ultravision Touch helps the operator accomplish this through an efficient and simple user interface. After merging the data files, the C-scan are stitched together with the ability to compensate for typical small misalignment and misorientation between datasets. The global C-scan image is then saved and ready to be used for further investigation. When the stitching process is completed, the merged data can be reviewed and analyzed just like any inspection data. This gives the data analyst the full confidence that all the component has been properly inspected and allowing full traceability over time. One of the most exciting features for the analysis is the possibility to visualize and evaluate the corrosion data in the 3D environment of Ultravision Classic Advanced. This can be done without any file conversion. The 3D rendering features will transform the 2D color into a realistic image of the corrosion damage pictured in the CAD drawing of the specimen. This type of imaging makes the result easier to communicate to non-NDE personnel. We have seen that the Zetec solution for corrosion mapping has a lot of benefits. With the Topaz 16, it is easy to set up for phase array inspection without the need of being an expert. The NDT paintbrush scanner makes corrosion mapping as simple as painting a surface, leaving no uncertainty left behind. The Ultravision Touch software offers a lot of advanced data analysis, like automatic wall thickness measurement, C-scan stitching for large specimens, and 3D rendering. With the corrosion solution, Zetec offers an integrated solution for corrosion mapping and wall thickness measurement on steel components. That concludes our presentation today. Please take the time to visit our website for more information on the various solutions discussed during this webinar.